So if f of x equals 2 to the x, and we want to graph y equals f of x plus 3, again, if f of x is 2 to the x, f of x plus 3 is 2 raised to the x plus 3. Okay? Well, we want to get the same values of y that we had in our original table. So we want to get values like 1/4, 1/2, 1, 2, and 4. We want to get these values to mimic these values, right? So the question now is, what does x have to be to give you each of these values? Okay? Well, I'll try to write out the logic of this, and I need a different color here. Okay, so two to what value equals 4?
2 to the second.
Yeah. 2 to the second equals 4. So we're doing 2 to the x plus 3, right? So x plus 3 would have to equal 4, right?
2 to x plus 3.
Well, what x would we put in here in order to get 4?
Negative 1.
I'm sorry?
1.
Would be negative 1.
Yep. So that's really what I'm doing here. So you see that right away. You see, we'd have to put negative 1 in here to get 4, right? Because we need the second power of 2 in order to get 4. That tells us that our x plus 3 has to equal 4, right? So and that's not right. X plus 3 should have to equal 2. Okay, our exponent has to be 2, right? So you figured it out before I did, because I was writing this down, and I carelessly wrote a 4 when we needed a 2, right? Which confuses the whole thing, so let's be sure we understand. Okay? Logic again. We want to get 4. We want to figure out what value we put here to get 4. Okay? Now, whatever x we put here has to go into 2 to the x plus 3. Okay? So what value would we put here in order to get 4? Well, we can reason that out. In order to get 4, the exponent has to be 2, right? 2 to what power equals 4? 2 to the second equals 4. Okay? So the exponent has to be 2. Well, you can see right away if x is negative 1, and you saw that. If x is negative 1, you're going to get 2 to the second, right? So we can bypass my error here by just saying, okay, we know that if x is negative 1, then we're going to get 2 to the second power, which is 4. Now, if we don't see that, we can say, well, the exponent has to be 2, and the exponent is x plus 3, right? So to get exponent 2, x plus 3 has to be 2, and you solve that easily, you get x equals negative 1, right? So there's two ways to see it. And actually, I'm going to write this out just a little differently to make another thing as clear as possible. X equals 2 minus 3, which is negative 1, right? I mean, that's a solution to x plus 3 equals 2. You subtract 3 from both sides. Okay? Now, what number would we have to put here in order to get 2?
-2.
Because this is 2 to the first power. You're going to have 2 to the first power here, so x is going to have to be negative 2, right? Okay? So, now we could have written it out here. 2 to the first equals 1. So x plus 3 would have to equal 1. 2 to the 1 equals 2. Okay, we want to get 2. That's 2 to the 1. Okay, we're trying to do 2 to the x plus 3, so x plus 3 would then have to be 1 in order for this to give you 2. Okay, well, you go on, you can pretty clearly see that we're going to get -3 here, -4 here, -5 here. You can figure out why that is, okay? But you see now that every x value is 3 less than it was over here. So we can say,
That's because it's 3. You include the 3 inside the parentheses, correct?
right, by including the 3 inside the parentheses, that changes our exponent to x plus 3, right? So to get the same values,
Probably like 10 minutes for
x has to be 3 less than it was over here.
Okay.
So So you get the same y values if x values are 3 less than they were for the f of x function.